The mystery of 3I Atlas has just taken a jaw-dropping turn. In our last videos, we uncovered its strange path and the wild theories surrounding it. But now, new observations claim something almost unbelievable. This interstellar visitor may be spewing water older than Earth itself into space. Not dust, not speculation, but signals that could rewrite the story of where oceans and maybe even life begin yet. The shock doesn't end there, because leading scientists are already pushing back. Tonight, we dive into the discovery, the doubt, and the cosmic stakes. The cosmic water bombshell. When news broke that 3I Atlas might be carrying ancient water, it wasn't just another headline. It was the kind of discovery that makes astronomers stop in their tracks. For the first time, a team working with NASA's Neil Gehrels Swift Observatory claimed they had spotted the unmistakable chemical fingerprint of water escaping from an interstellar comet. Between July 31st and August 1st, 2025, Swift's ultraviolet/optical telescope locked onto 3I Atlas, scanning for faint ultraviolet emissions. The target was specific, a signal at 3,085 angstroms. This narrow band corresponds to OH, hydroxyl, formed when sunlight breaks apart water molecules. Detecting OH is the gold standard. It doesn't suggest water might be there. It proves water is breaking free into space. And that's exactly what the team saw. The numbers were staggering. Based on the OH glow, 3I Atlas is shedding water at a rate of 1.35 times 10 superscript 2 molecules every second. That's roughly 40 kilograms a second, pouring off an object from another star system. But here's the twist. Put differently, in less than a minute, this comet could release enough water to fill an Olympic swimming pool. And this is happening while the comet is still 3.5 astronomical units from the Sun, farther than Mars. At that distance, most comets are sluggish, still frozen tight. But 3I Atlas is alive, outgassing as though its icy veins can't be contained. How can this be? One possibility is that the comet's surface is unusually rich in exposed water ice, covering perhaps 20% of it. Another possibility is more subtle. Small icy grains are being wafted into the coma, the fuzzy halo around the comet. As these grains drift, they sublimate, releasing water gas that glows under ultraviolet light. Either way, the conclusion is extraordinary. This is not just a faint whiff of gas. This is robust, measurable activity from a visitor born under a different star. It's also the first direct look at what these alien wanderers are truly made of. Oumuamua, the first interstellar object ever discovered, left behind more questions than answers. Borisov, the second, looked a lot like an ordinary comet. But now, 3I Atlas delivers something new. Hard evidence that interstellar comets carry reservoirs of water. Water that has likely been frozen for billions of years, preserved in the cold dark of interstellar space, only to erupt in our skies when heated by the sun. For scientists, this is a dream. A chance to study the chemistry of distant planetary systems without leaving home. For everyone else, it is a moment to marvel. Because if water is not unique to our solar system, but flows freely across the galaxy, the implications stretch far beyond astronomy. But before we celebrate too quickly, we need to ask, why does this discovery matter so much? And what could it really mean for us? Secrets frozen before Earth. Finding water in an interstellar comet is not just a scientific footnote. It's a revelation that ripples across some of the biggest questions humanity has ever asked. Where does water come from? How common are habitable environments in the universe? Could life's essential ingredients travel between stars? 3I Atlas is not an ordinary comet. Its path and velocity reveal its origin, not from our solar system, not even from the Sun's neighborhood of stars, but likely from the Milky Way's thick disk. That's a region filled with some of the galaxy's oldest stars, many of them billions of years older than the Sun. If 3I Atlas was born there, it could be anywhere from 7 to 14 billion years old. In other words, the ice now vaporizing into space may have been frozen long before Earth itself formed. The thought is staggering. Picture an object wandering the galaxy for eons, crossing star systems, drifting through cosmic dust clouds, carrying inside it water older than the continents, older than our oceans, older than Earth itself. And now, for a brief moment, it passes within reach of our instruments. To find water on 3I Atlas suggests that water-rich comets are not rare accidents, but common products of star formation. If they exist around other stars, they may deliver water to young rocky planets, seeding them with the conditions for habitability. This feeds into the theory of panspermia, the idea that the building blocks of life may travel through space, hopping from one system to another, spreading chemistry like pollen on the wind. But here's the kicker. At 3.5 astronomical units, comets in our system are usually dominated by carbon monoxide or carbon dioxide outgassing. Water tends to stay locked up until they get closer to the sun. Yet here, water is already flowing in vast quantities. Either 3I Atlas formed in a region unusually rich in water ice, or it is being cracked open by mechanisms we don't yet fully understand. Both possibilities expand our models of how comets form and evolve. And here's the most unsettling thought. If confirmed, this discovery connects our oceans to a far greater cosmic cycle. Earth's water may not be unique. It may not even be local. Instead, it could be part of a galactic circulation, with interstellar comets as couriers delivering water across the stars. That possibility forces us to rethink our place in the story of life, not as isolated, but as part of a continuum stretching across light years. And yet, while the idea inspires awe, it also invites scrutiny. Because in science, every claim must be tested, and not all astronomers are convinced. Clash of theories, the battle for truth. No sooner had the excitement spread than doubt followed. Some scientists warned that the evidence, while intriguing, may not yet be ironclad. The OH signal, they argued, could be an artifact of noisy data, a misstep in calibration, or even the byproduct of other gases masquerading as water. Until additional observations confirm it, they caution the comet's watery secret must remain uncertain. Skepticism may feel deflating, but it is the engine of science. Every extraordinary claim is forced to pass through fire. Spectroscopy, the method behind this detection, is a tool of both immense power and delicate sensitivity. Identifying faint chemical fingerprints from millions of kilometers away is like listening for a whisper in a hurricane. A single error in correction or a hidden line of interference can mimic the voice of water. That is why astronomers demand repeatability. It's not enough to glimpse the signal once. It must be seen again and again before we can declare it real. Others add more nuance. Perhaps the OH emission is real, but its source is ambiguous. It might not be water sublimating directly from the comet's surface. Instead, icy grains could be floating within the coma, gradually releasing gas as they drift. Or maybe more exotic ices, like carbon monoxide and carbon dioxide, play a role, creating overlapping signals that cloud the picture. This clash of interpretations is not failure. It is the drama of discovery. We are watching the scientific method unfold in real time. Claims, counterclaims, questions, and tests. Each new observation adds weight to one side of the scale or the other. The suspense lies in not knowing which way it will tip. And that's why 3I Atlas grips us so tightly. It is more than just a comet. It is a stage on which truth and doubt wrestle for dominance. 3I Atlas arrived as a wanderer from another star. Today, it stands at the heart of one of the most electrifying debates in modern astronomy. Did scientists truly glimpse water older than Earth, spilling into space before our eyes? Or will the signal dissolve under sharper scrutiny? And here's the bigger question. If water really flows between stars, could life itself be a traveler too? The answer will shape how we understand life's most vital ingredient, whether as a rare gift or a galactic inheritance carried between the stars. Thanks for watching. We'd love to hear your thoughts in the comments. If you enjoyed this video, don't forget to like, share, and subscribe. Your support means the world and keeps our journey going.